90.9 times 10 to the 6th per second. All right, and that comes out to be 90.9, 6 times 626 E minus 34 times 90.9. 6262 E minus 34 times 90.9 E6. There we go. So that comes out to be 6.02 times 10 to the minus 26 joules. Okay. All right. Okay. So I'll leave these for you for more practice. Okay, for going back and forth between frequency and wavelength, and then energy. Okay, so it's exactly what we did. Oops, over here. Okay. So let's talk for sort of a brief minute, okay, about when we have lots of photons or lots of packets of light, right? So I told you that certain types of radiation could knock electrons out of atoms, okay? And when we were looking at the red versus the violet light, and when you increase the intensity, you get more you can get electrons coming off with the violet light, but not the red, okay? So we can also talk about the ability to break chemical bonds. Okay, so I'm just going to tell you, okay, that a bond between two carbon atoms, okay, has an energy of 346 joules per mole. Okay, so that means if you have 1 mole of carbon-carbon bonds, okay, it would take that amount of energy, okay, to break those bonds. Okay, so what we're gonna ask is if we had a mole, okay, of 230 nanometer photons, okay, is that enough to break that bond? Okay, so, oops, remember we're treating our photons like they are little objects, and a mole is Avogadro's number, 6.022 times 10 to the 23rd, okay, objects, right? All right. Grab a calculator instead of my phone. All right. So we've got 230 nanometer light. So in order to turn that into an energy, okay, we got to know what the frequency is, right? So and then what we do is we figure out the energy of 1 photon. And then we figure out the energy of 1 mole of photons. All right, so this is kind of a 3-part thing, okay? So I now see why I had these previous questions, okay? So we've got our 230 nanometer light, okay? So we are going to be using, the relationships we've used here, okay, to figure out what our frequency is, okay? So our frequency is going to be speed of light divided by the wavelength, okay? So we've got our frequency is speed of light divided by the wavelength, 3 times 10 to the 8th meters per second, divided by 230 times 10 to the minus 9th meters. Okay. So that comes out to be 230 E minus 9. That comes out to be 1.3 times 10 to the 15. Okay? And the unit of that is going to be hertz or inverse seconds. Okay? All right, so now our energy of one photon is going to be Planck's constant times the frequency. So that's going to be 6.626 times 10 to the minus 34 joules per second. And we're going to take our frequency. Okay, so we've got that, multiply by 6.626 times 10 to the minus 34. That comes out to be 8.64 times 10 to the minus 19. Okay, and that is joules. Okay, so that's for one photon. So now we'll take this, and that's where we're going to start with, okay? So here is our energy of one photon. That's that right there, okay? And we're just going to say if we had a whole bunch of those, if we have Avogadro's number of them, the energy of a mole of photons of that wavelength of light is going to be Avogadro's number times the energy that we figured out would be for one. Okay, so 6.022 times 10 to the 23rd. That comes out to be a honkin' big number. It is, so the energy of the mole of photons, 230 nanometer photons, comes out to be 52045.8957. All right, should have rounded there. All right, so that comes out to be 520,000 joules, okay? Is that more than 346 joules? Yes, it is, all right? So the answer to this question is yes, many times over, okay? All right, you know what? We're not going to cover all of section 3.3 in 4 minutes. So that's not going to be on the exam, okay? Thing number one, okay? Not on the exam. All right, and what I want to do now, okay, is have you chat with your neighbors, okay? And today's team question is pick one of the chapters that we cover on the exam, that will be covered on the exam. Chapter 1, Chapter 2, or the first 2 sections of Chapter 3, okay? And I want you to say, okay, we're thinking about Chapter 1, or we want to talk about Chapter 2, and tell me what your group thinks is the take-home message for that chapter.